boy, do I miss you guys. You are so much fun, and I usually need the help and everything. Now I'm like, they usually help me find things around class and help remind me and everything, but know that Mrs. G is missing you guys, and I wish I could be back in the classroom with you before this baby comes and everything. But in the meantime, you are more than welcome to FaceTime me, you can message me, you can email me, you can do whatever you need to. A lot of your parents do have my number, but we're not getting into that. So, as a quick little reminder, we are going to have a homework assignment due every Friday from me and vocabulary. Not every week vocabulary, but those are the only two assignments I expect back from you guys. Vocabulary and your homework assignments. Please be quiet. They're playing video games upstairs. We got a new video game system. Anyway, so this week we're going to be learning about motion, position, speed, acceleration, and velocity. 5 vocabulary words. And you're probably thinking, oh my goodness, there's so much. It really isn't, because it's all connected. So, get your notes ready. I've got my 5 whiteboards here with tons of markers ready to go. The first word we're going with is motion. It actually goes with position. So we've learned about this with potential and kinetic energy, because this is all the same. Motion. Ta-da! Think of locomotion, that song. You guys are too young to know that. But motion. So here's your vocabulary for this. Look at that. I'm helping you out with one of your assignments. It means change of position. That's easy. Bam. Motion means change of position. So in position is one of your vocabularies. Might as well underline that. It means where you are, where you're standing at. So motion means to move, to go somewhere else. So something as simple as waving this board, writing with my marker, driving in a car, the earth turning. I mean, it's all motion. It's all easy stuff. Something going from one place to another. That was hard. Okay, so now get some more notes. Here we go again. Should I change colors? Why not? I have like the whole rainbow over here. Ta-da! Blue. Okay, next word. Well, I guess it's word. Reference points. You're thinking, wait a minute, that wasn't one of the 5 words you introduced. This one's very important, guys. Reference points. So you need to write that down, okay, as part of your next words. And it is a vocabulary word. Reference point. This is where you describe where something is. So you might be going, well, wait a minute, isn't that position? Technically, it's kind of the same thing, reference point and position. But the reference point, actually, guys, is what you refer to when you're trying to test speed. So here's the thing, okay? If you are walking down the highway, please don't walk down the highway, but if you're walking down the highway and then like a truck passes by you going 30 miles an hour, it's kind of slow for the highway, isn't it? But you get the point. Then your reference point is where you are, where you're standing when that truck passes you. So the motion, the speed is what we're going to get into. The speed is 30 miles in one direction. That is what's going on. Reference point is where you correlate or you predict how fast something's going. And here's the funny part. If you were in a car next to that truck and you're both going 30 miles an hour, does it look like you guys are moving? The funny thing is no. Because you're going the exact same speed, you're traveling at the same distance at the same time with speed. Neither of you are going away. So your reference point is that truck. You're checking yourself. So you guys don't have very much motion. But if you're standing to the side and the truck passes you, then that is reference point. Mileage going. Here's the weird thing. Have you ever thought like the world spins at like what, 1,000 miles? I'm off probably on that. But you're like, we're spinning so fast that we don't ever notice. The reason why is because our reference point where we're standing and then we look at something, we're both turning and moving at the exact same time. So therefore it doesn't look like we're moving at all because we are at the same speed. And acceleration, not acceleration, we're at the same speed. But if I was to stop and then that other object kept moving with the earth, then of course I'm going to notice because my reference point is right here versus where that object is. It's kind of a lifelong question a lot of people have asked. So once again, we have motion, change in position, and we have reference point, where it is we compare movement to. Change colors. I got green this time. The next one is speed. So I brought this word up with the reference point, and we want to learn about it. Speed, can you guys guess? It's how fast something's going. That's easy. But you know what? Let's make it more fancy because we're in 6th grade. It's the distance traveled in a certain amount of time. This is a long one, right? But I know you guys are keeping up with me, right? Speed. The distance traveled in a certain amount of time. Speed isn't just the motion you did. It's actually calculating how fast you're going. So the reference for that, because you guys, this is your homework assignment is actually to calculate speed. We're going to put S. So S equals change of distance. Sorry if I'm turning my head a lot. It's because I got my notes written down, so if I forget. Change of distance, which is measured in meters, sometimes feet, but usually meters. And change in time, which is measured in seconds. Divide it. So write that down under speed. S is speed equals change of distance, how far you go, divided by how many seconds you do it in. So then your speed is, the rate is miles per second. That's why we always say mph, or miles per an hour for that one. Oh, good. You want that? Rora, come down and help Jotham, please. He's trying to be superhero. So that's speed. So we go from motion, changing in position, to reference point to how fast. And speed is we calculate our speed, and then we can tell from a reference point how far it's moving. Now this is where the fun part starts coming in, where you start to get into your challenges of building your roller coasters and everything. Good thing I have a lot of these. I'll go brown for this next one. Velocity. There's your word, velocity. This is speed in certain directions. Speed in certain directions. So if I'm traveling northbound, that's my velocity. That's my direction. So I'm traveling northbound, that's my velocity. And the speed, it's how fast. Velocity is how fast am I traveling northbound. Now here's the thing. Velocity can change. The change can come in either speed or direction. We're writing that down for you. All right, so all of a sudden you can be going the same speed, but mom and dad say, oh no, I missed that turn. And then they forget to slow down, which I'm sure you've experienced, and I'm guilty of it too. You turn that corner, and you don't change your speed, but what else do you change? You change your direction. That's velocity. So you keep the same speed, but the direction and everything and direction are going a different way. So when a speed changes or the direction changes, velocity takes place. Pretty cool, huh?
Mommy.
Go ask Aurora. Go ask Aurora, please. Good thing I have an old kid. Last one's acceleration. Bam. This one's awesome too. So we go from motion to reference point to speed to velocity to acceleration. So you're like, oh man, yeah, that's like put on the gas and going 100 miles an hour. Not exactly, guys. Acceleration is actually the rate at which velocity changes. So it's another calculation. So velocity is the change that's taking place. But acceleration is the calculation, the number of what that change actually is. So it can be measured in 3 different ways. Measured by speeding up, slowing down, or changing directions. And yes, there is a math formula to go with it, but I'm not worried about that right now. I'm more worried about getting what acceleration actually is. Because, just because you think the word accelerate means to speed up, no, acceleration is actually the change in velocity. So if you are changing direction, you are doing something different from the speed. Oop, I forgot to add a word. Let me put those notes back up for you. Okay, acceleration, the rate of which velocity changes. It can be measured by speeding up, slowing down, or changing directions. Just realized I didn't put the up part on that one. I have a feeling one of you would have caught that, and then you would have gotten an extra 25 points. So if you do catch a mistake at any of my videos, feel free to let me know, and I'll be happy to give you lab points for it. Here's the great thing about acceleration. So I want you guys, if we're allowed, by the time I post this video, have mom and dad or somebody, have one of them take you out in the car. Just go for a drive, okay? But squish all of your siblings and you into the back seat. Make sure everyone has a seatbelt, okay? And then when mom and dad turn the corner, what usually happens when they turn the corner and whatnot? Right? Everyone starts getting squished and everything. That's acceleration taking place. It's a change in the velocity. We've changed direction, so now we're experiencing something. We're going to calculate out how much that change actually happened. It's really cool. So you can actually have some fun with it. And also, have you ever been on the Scrambler? Oh, man, I love that ride. But the thing is she always puts the person who's the biggest person, like me compared to Jotham. She put me on the inside, which is the left-hand side, which is different from what I'm showing you guys, because they're the ones that get squished the most. So if your parents tell you, no, go on the left-hand side, and because they know acceleration is taking place, and they're going to squish you like a bug. So those are our notes for the week, okay? So here's the fun part. I've got 2 experiments for you guys to try, okay? These are not kidney beans, okay? Get a note card. Don't have a note card, get cardstock or something that's like a really good thick paper, okay? Make a boomerang out of it. So practicing this. So what you should be able to do is, how does a boomerang work? Okay, so you're like experimenting with velocity and acceleration and everything. Because if somebody goes in a circle, guess what? It's constantly changing velocity because the directions are constantly changing. If you're not going straight, velocity is taking place. Okay, so now, if I do this right, if I throw it, it's supposed to come back. Okay, so if you do it just the right angle. That was not successful. It just fell on the ground. Okay, I got another one. Okay, ready? Maybe a different angle. Okay, well that did not work. But most boomerangs should actually, when you throw them at a certain angle and a certain weight, and the bouncing of it should come right back to its reference point, to where it started. The motion was taking place. So my position didn't change, but it was happening in acceleration. Here's another fun one to try. This one's going to take a couple times. Okay? Start with 3 coins. 1, 2, 3. Okay? To begin with. Put it on your shoulder, on your elbow. Okay? And then, whoop. Doesn't work very well with my shirt. Let me see if I can fix it. Okay? Put it on there. And what you want to do what you want to do is that you want to be able to catch them. So you have to do this and figure it out. After a couple of tries of doing it, by swiftly changing the velocity and everything and going in a different direction, eventually you should be able to catch those coins. And you can use any coins. It's okay. Pennies work. Every time you catch them, though, add another coin and see how many you can get. But that's just a fun little experiment to try that we would have tried in class to really get used to what motion and velocity and everything are. Maybe if you guys actually do it and you're successful, take a video of it, send it to me, and I'll give you lab points. Assignment for this week. Okay, so this is what you're going to do. Your homework assignment is to calculate speed. How to calculate speed. I've uploaded the documents onto RunWeb, so all you have to do is look for the title, How to Calculate Speed, 6th grade, and it should be there. You can either print it off and answer it and then send me a picture, or you can just write on a piece of paper the answers. It tells you how to calculate, just like we had notes on, speed, but I want you practicing it to get an idea. So play around with these experiments, complete your homework assignment, give it to me by Friday, send it to me by Friday, and you do have vocabulary words up on RunWeb as well. Remember to define it, picture it, and give me a complete sentence. You can write it or you can type it up, whatever's easiest for you, and send it to me. This will not change. Video every week, notes every week, science experiment to do at home just for the fun of it, and homework assignment and maybe vocab. So 2 assignments due to me. Now, Wednesday, you'll see on the lesson plans, you'll see on the lesson plans that I've uploaded enrichment activities. These are just voluntary. They're things, extra things you can do to dive deeper into this learning. So we would have done this stuff in class, but it's a fun way to just get your brains going a little bit more. But here's the thing. Lab wars are going to be different this 9 weeks because I can't really divide you guys up and keep track of those. We're going class against class. So, and you guys are at an advantage because you have well, you had 16, now you have 15, but you're still one of the bigger classes. So to make it fair to 7th and 8th grade, your enrichment activities aren't worth as much as theirs, but they have to work a little harder in order to get those points. So here's the thing. If you complete an enrichment activity, you send me either 2 ways to show me proof. You either write me a paragraph that says what you learned from it, so I'm talking like a full 5 to 8 sentences, completes grammar, everything. Or you take a picture of the assignment you did, that enrichment activity, excuse me, or a video. I need some water, that'll probably help. If you do the enrichment activity, you can do 1, you can do all 4, it's completely up to you. You don't have to do any of them. But if you want your class to actually win the lab wars, go for it. The big thing is it's not going to be a free lunch, but it's going to be a party at Mrs. Greenwald's house this summer when we're out of quarantine and everything. But, so let me go through. I think I've got everything accomplished and everything. So there was your notes for the week. If you guys have any questions or you want to just talk to me or FaceTime, whatever it is, I'm here for you guys. Know that we're here to talk and to work and to collaborate. You can work with other people on any of these enrichment activities. It's up to you guys. But you're working as a class to try to beat the other classes. So who's going to dominate this time? I don't know. 6th grade's been doing pretty good. And that is the video for this week. I can't wait to hear from you guys and see some of the creativeness that you guys come up with. Send me a video of if anybody's successful with the boomerangs or the flip of the coins. And hopefully next week I'm not interrupted everywhere. I miss you guys. Have a great week. Know that God loves you and that I deeply miss you and I love you all as well. See you next week.